This is part 5, talking about David Deutsch's book, The Beginning of Infinity. Like last time, we're going to talk about induction. It's a big topic, I can't fully cover it, but we're going to do a bit more, and then we'll get back to the book next time. Last time we looked at forest photos and number sequences. The point was to try to challenge some of the intuitive plausibility of induction and show some of the gaps in its claims. This time we're going to look at something about the infinity of possible patterns. And I've tried to make it simple enough that it could be intuitive to people. So the first question is, what's a pattern? Which is actually a really hard, difficult, tricky question. So there are multiple types of patterns, but to keep things relatively simple, we're only going to look at one type, which is you have a sequence of numbers and it repeats infinitely many times. That seems like pretty clearly that should count as a pattern. So, for example, you have 1, 2, 3, 1, 2, 3, 1, 2, 3, etc. If that repeats infinitely many times, we're going to call that a pattern. We're going to write it as 1, 2, 3 in brackets with a ... afterwards to show whatever is in brackets repeats infinitely many times. So, let's say we have our data, like 7777. This is our data set. We've done some observations of reality, and that is how they came out. This means that we were measuring something. Like that could be, we measured it every 1 minute and it was 7 inches every time. And then from that, you might want to try to predict, next time we measure it, how many inches will it be? And you could predict many different things. Maybe in the next minute, it will become 8 inches, it'll grow. Maybe it'll become 6 inches, it'll shrink. Maybe it'll become 1,000,000 inches, it'll grow a lot. Some of these guesses sound intuitively more plausible than others, and that's why induction seems intuitively plausible to people. And there are reasons. I just think there are non-inductivist reasons why some of the guesses are more plausible than others. Anyways, so what patterns could it be? The idea is we take this data set, these 7s, and we consider what patterns could these be a part of. What is a larger sequence of numbers that forms a pattern that our observations could fit within? So one of the options is it could be infinitely many 7s in a row. But there are other options that are also patterns. So it could be all of those 7s we got, and then a 1, and then that entire group infinitely repeats. So it would be 7 7 7 7 7 7 1, 7 7 7 7 7 7 1, 7 7 7 7 7 7 1, and so on. That is an infinitely repeating pattern. It clearly is a type of pattern, and it fits our data. If this was the pattern that nature was doing, and we did our observations, and we took our 7 observations and we got 7 every time, that is exactly what we'd expect if this pattern right here was how reality works. If this is how nature works, then we would predict the exact data we got, so it perfectly fits. And then there are other options. It could be all those 7s and then a 2. And then all of that infinitely repeats. Or all those 7s and then a 3. And then all of that infinitely repeats. Or all the 7s and then a 4. And then that infinitely repeats. So, as you can hopefully see, there are infinitely many ways to do this, because it could be a 5, or a 6, or a 7. And there are many other patterns. We could have ones with more numbers in them, like it could be a 3, and then a 22, and then a 5, and then we put our bracket and ... it. It doesn't have to be a single number. A single number is just the simplest way to do it. We're tacking on one number on the end and making the whole thing infinitely repeat. And the point is, there are infinitely many patterns. So, instead of saying find the pattern, what you need to think is which patterns are important and why those. The problem is not how to find a pattern. It's easy to find infinitely many patterns. And induction, by saying find the pattern, it's looking in the wrong place. It's misunderstanding what the hard problem is. So, looking at the same thing again. If we have arbitrary data, if we have data, we can predict what comes next. And it could be any arbitrary data comes next. And then we can take the whole thing, the original data, plus any arbitrary prediction, we can say that is an infinitely repeating pattern. So if your data is D, we could have D repeating, we could have D and then a 1 repeating, we could have D and then a 2 repeating. It could be D and then anything, and then the whole thing repeats. So D, comma, and then arbitrary data, square bracket, ... This could be our pattern. So our original data plus anything at all, and then it all repeats. So, conclusion, infinitely many patterns fit your data. So to choose between them, we need something other than induction. Induction is not going to guide us adequately. So finding patterns is not an accomplishment. They're easy to find. And this is uncontroversial. There's no mathematicians who are doubting this or something. The better inductivists already know this. Sometimes they mention it in their books in some manner. It's been an open problem for over 2,000 years in some form. Maybe not this exact form of the problem, but people knew induction didn't work and knew some of the basic problems with it for a long time. So it's a bit weird that people still, to this day, seem to be pretty confident that induction will one day be fixed. Why not look elsewhere? Maybe there's something else other than induction. Induction's been so stuck, you should be open to alternatives. There are some attempts to answer the infinitely many patterns point. I don't think they're very good. They're too tangential. I'm not going to get into them now. If you're familiar with one and it seems convincing to you and you can't see anything wrong with it, you can ask at curie.us website, start a discussion, and you can get some answers. So the big thing I want you to remember when people bring up induction stuff is the question which. So someone says, find a pattern, that's what induction is about. And you say, which pattern? Or if they say the future is similar to the past, you say which similarities. Or in other words, which things are similar over time? Which ways is the future similar to the past? The fact is, no matter what happens, the future will be similar to the past in infinitely many ways, and also dissimilar to the past in infinitely many ways. All possible futures would have infinitely many similarities and dissimilarities, for reasons very similar to the infinitely many patterns I was showing you earlier. Induction says correlation hints at causation. By the way, there's many variations of induction, so they don't all say the same things. This is just a common one that you often hear from inductivists. So if they say that, you should be thinking, which causation does the correlation hint at? Why that one? There are infinitely many causations that would explain that correlation, that would, if that causation is true, we would expect to observe that correlation. And also, which correlation should we look at? Because there are infinitely many correlations. Correlations are essentially just patterns. So whenever we look at our data, we're going to find infinitely many correlations. And then people are like, well, the correlation probably hints at causation. Well, which correlation? Are you saying there are infinitely many causations going on? That's not going to be very helpful or give us much guidance about what to think. So induction says, this evidence supports this theory, and you should be thinking, which theory should the evidence support? Why that one? What about the infinitely many other theories that also fit the evidence? There's a really standard inductivist response to that. They tend to think that evidence supports theories by different amounts. So the answer to which theory is the evidence supports some theories more than others. So you take the theory that is supported the most, and that is the one you should be focusing your attention on. And there are some problems with that. My view, and BOI's view, David Deutsch's view, is evidence is either compatible with a theory or it contradicts it. So either there's something that makes them incompatible, they don't work together, or not. But inductivists think that they agree with that first part, that either it's compatible or it's incompatible, but they say if you have evidence that's compatible with a theory, then it could be highly compatible or highly supporting or just a little bit. It could be any varying amount. So there's a question, how is it determined which evidence supports which theory by how much? I've asked this question to a lot of inductivists. I've never got anything resembling a decent answer. So BOI's view, David Deutsch's view, is that evidence either does or does not contradict a theory. There's no amount of contradiction or amount of support. In fact, there's no support at all because non-contradiction is not support. The concept of support is a misconception. It doesn't fit the actual situation. Non-contradiction is the actual thing. You have evidence and either it does or it does not contradict your theory. It either rules your theory out or it doesn't rule your theory out. It either fits your theory's predictions or it doesn't. Also, to know whether evidence contradicts a theory requires interpretation, analysis, having a model of reality, having explanation, stuff like that. So, there's an underlying reason that the math stuff doesn't work out well for induction. The issue is, induction is trying to solve a deep fundamental problem about how thinking, learning, and intelligence work. So, no common sense or intelligence can be allowed to fill the gaps in induction's procedure. Otherwise, you run into circularity, because you're saying intelligence works partly by intelligence. If induction is trying to solve the problem of how intelligence works, it cannot rely on intelligence to make it work. You can't already have intelligence when you're trying to explain how intelligence works. This is really counterintuitive to people. They always want to use common sense to defend induction or to reject some stupid pattern that they think looks obviously not very useful. But induction is supposed to be prior to common sense, prior to your judgment of what is good or bad, reasonable or unreasonable, etc. If you change induction and you say, oh, it's going to be just a method of how to use our intelligence, then you're no longer offering a rival theory to critical rationalism about how intelligence works, how learning works, how those fundamental things work. You'd already be conceding almost everything that BOI cares about, which is that learning works by an evolutionary process of guesses and criticism. And historically, induction tries to challenge that and be a rival to that, but some people have retreated from that. In which case, I'd still disagree with them, there's still issues, but it's not even very relevant anymore if they retreat from making claims about the important issues, like how thinking and learning work. So, recap. Any set of observations fits infinitely many theories. Patterns are easy to find, they're abundant, not scarce. Finding a pattern is not a major accomplishment, same with similarities or correlations. The difficult thing is figuring out which ones matter and why those. There are always many, many theories that fit our data. Finding a theory that fits our data is easy. The hard thing is judging which ones are good using criticism. Induction cannot rely on common sense if it is supposed to explain how common sense and intelligence work in a deeper way, if it's supposed to be prior to them. And induction is a complicated topic, there's more to it, we didn't cover it all. But I think this is enough to help people understand a bit more than the passages in BOI covered. If you like this, sign up for my free email newsletter. Go to fallibleideas.com, click on newsletter. In part 6 next time, I will be continuing with the text of the book. We'll be reading further.